Greetings to you all. Today I will be giving a presentation on how the crested guinea-fowl responds to changing land use in Isimangaliso Wetland Park. Habitat loss is one of the significant threats to the survival of many terrestrial species, and over the years we have seen the conversion of natural environments for practices such as agriculture and livestock farming. Globally and in South Africa, there's been an increase in the conversion of natural environments for plantations, and these generally have a negative effect on many species, in the distribution and occupants of many species. And the impact of this plantation on ground-dwelling birds include the declining in numbers because of loss of habitat and nesting sites. And usually in plantations, the undercover story is very low if there is no undercover story in many plantations. Therefore, there's going to be an increase in predation risk. And for forest specialist species are species with specific ecological niches. Therefore, any changes happening to those areas with specific ecological niches can possibly result in the extinction of the species. This is how a forest looks like before conversion. This is how it looks like after being converted for plantations. Our study site was the crested guinea-fowl, which is a forest specialist, usually in flocks of 10 to 30 individuals. It is an omnivore species. According to the IUCN, the species is listed as least concern. Literature has shown the importance of conserving such species since they also play a crucial role in structuring many ecosystems. This is just the distribution of the crested guinea-fowl. The objective of the study was to investigate the influence of habitat conversion and habitat characteristics on the occupants and distribution of the crested guinea-fowl. We hypothesized that changing land use, particularly plantations, will have an effect on crested guinea-fowl occupants and distribution. And we predicted that the crested guinea-fowl are associated with natural forests. People usually ask, why did we choose a forest specialist species? I think it is ideal for management decision. It is ideal to use specialist species because they will indicate the impact that changing land use will have, or the detrimental impact the changing land use will have on the survival of that species. Our study site was Isimangaliso Wetland Park. Although it is a protected area, some parts of the park were being utilized and are still utilized for plantation. However, the plantation are completely removed from the eastern shore and partially from the western shore. And the effects of this, especially on wildlife, are not well documented within Isimangaliso Wetland Park. This is basically the eastern shore, how it looks like, and this is the western shore. Using ArcGIS, we created 2 kilometer systematic grid, and within every grid we had one camera trap. And the average distance between the camera trap was 1.7. We placed the cameras, we use passive infrared camera traps, and we placed the cameras 30 centimeters above ground level, and we partially removed the vegetation around the camera in order to avoid blank shots. From the data, we created the binary matrix of where 0 indicated the absence of the crested guinea-fowl in that day, and 1 indicated presence. And the cameras, we had 99 camera sites, and we left them to run for 24 days, both during the day and night. These were the sites of our cameras, and within every site, around the 15 meter radius, we collected the weed dominance, the number of trees, canopy cover, shrub cover, and herbaceous plants, their cover. We also determined the amount of leaf litter within that 15 meter radius. For narrow and wider parts, if a camera was installed near a narrow part within a human trail or animal trail in the park, it was considered to be in the narrow part, and if it was put in the data management roads within the park, it was in the wider part. To determine the land use cover around each camera trap, we used ArcGIS, and we created a 1 kilometer buffer around each camera trap, and we quantified the percentage of natural forest and plantations. We did that at 500 meters and also 100 meters in order to see if there was going to be a difference if we at other scales. Using program present, we determined occupants, which is the proportion of an area occupied by a species, and we used we found detection probability, which is the likelihood of detecting the species within an area. Occupancy program present usually helps us to see the important variables for occupants and detection probability for the species. We used a single season model occupancy. Firstly, the PSI is for occupancy. Firstly, we created models with all the variables for occupancy, and then next we created for detection probability, which is P, and then lastly we created the models with both occupants and detection probability. And from present, we saw that we used the ICAC information criteria in order to determine which models were the best models, and all the models with delta AIC less than 2 or equal to 2 were considered to be the best model. And within those models, with the coverage within those models were the important variables for both detection probability and occupancy. And it was pretty much it was the same in all. It's 1 kilometer, 500 and 100 meters. For all our important variables, the five of them had a positive influence on other occupants or detection probability. However, narrow part was the one that had a negative impact on the detection of the crested guinea-fowl. To show you some of the results, we can show the probability of occupancy with natural forest, and as you can see, the R squared here indicating that this was the most important variable for the detection for the occupants of the crested guinea-fowl, and this the shrub cover was also one of the important variables for occupancy. From our results, natural forests were the important variable because the species primarily use these areas as their habitat. That is why it was important for its occupancy. And then the weed dominance and shrub cover were important because most ground dwelling birds, they use these areas for breeding, nesting, and as roosting sites. The leaf litter, since the species is an omnivore, it feeds on both seeds and invertebrates. Usually, the invertebrates hide underneath the leaf litter from the forest, from the leaves in the trees, and then the narrow parts, if you remember correctly, the narrow parts had a negative influence on detection probability. We assume that because the narrow parts within the park, or generally narrow parts, are used by the mesocarnivores such as hyenas, so we assume that it was because of that predation that it had a negative effect. From previous studies, we've seen that plantations do affect the occupants and distribution of ground-dwelling birds. And contrary, Ramesh and Dance found that plantation influenced the occupants and distribution of the red-necked spearfowl. And Benham and colleagues discussed that specialists are the most affected one by changing land use. To conclude, plantations limit the distribution of the crested guinea-fowl, and they result in habitat loss. And therefore, we call for better management of natural forests in order to protect the birds and then their nesting sites. I would like to thank the University of KwaZulu-Natal and the Hans Huysen Charitable Trust for funding the project. We thank Isimangaliso Wetland Park and KZN Ezemvelo for allowing us to work within the park. We thank Miss Enhle Kezwa for insights and help during the project. Thank you very much.